So for the 2018 exam, free response question number 3, you're given the graph of G and it's made up of piecewise function from -5 to 3, and then a quadratic from 3 to 6, okay? And they tell you that this graph of G, the graph of the continuous function G, the derivative of the function f. So G is f prime. So G, I'm going to write right here, G is equal to f prime, okay? The function G is piecewise, and then from -5 to 3, and then it's the quadratic again from 3 to 6, okay? So question number A, or part A, if f of 1 equals 3, what is the value of f of -5? So let's go to our paper and let's do that. Because we're given f of 1 and we want to find f of -5, and we have the graph of f prime, okay, I'm going to want to integrate from -5 to 1. And that way I'm going from left to right. I'm going the correct order, okay? So I know if I graph or integrate from -5 to 1, f prime of x dx, I know that that's going to come out to be f of 1 minus f of -5, okay? And so if I move, because I have minus f of -5, if I move that over to the left-hand side and the integral to the right-hand side, and f prime of x becomes g, right? Okay, so then I would have f of -5 is equal to f of 1, and then because I'm moving it over, it's going to become minus the integral from -5 to 1. And instead of f prime, I'm going to write g, okay, because they're the same thing. Okay, because f prime of x is equal to g of x. Okay, all right, so I know this one is 3, so that's going to be the start. Okay, so f of -5 is equal to 3 minus, okay, and then I'm going to use areas to figure out the integral from -5 to 1. Okay, so from -5 to 1, okay, I'm going to break this up. One way is you could see this as a trapezoid, okay, or you could see it as a rectangle and a triangle. You could do it that way too. I'm going to do it as a rectangle and a triangle. So I know, because the scaling's by ones, that this is going to be 3 by 3, right? Okay, so 3 by 3. So minus 3 times 3, okay, and then plus, and you know what? That's below, so I need to do a negative here, okay? So -3 times 3, and then minus 1/2, and then that's 1 times 3, or 3 times 1, okay? And then to 1, then I need to do this one, right? So 1/2, 1 times 2. So plus 1/2, 1 times 2. Okay, so why are these two negative, these two areas? It's because it's below the x-axis and we're going left to right. Okay, and why is this one positive? Because that one's above the x-axis and we're going left to right, okay? All right, so this becomes 3, okay, and then minus, and this is -9, and this is minus 3/2, and then this would be plus 2/2, right? Or 1, you could write it 1, 2, all right? So this becomes 3, and I'm going to make this plus 9 plus 3/2 minus 1/2. And you have a numeric answer here. So if you stopped here on the AP exam, you'd be right, okay? Okay, you can clean this up a little bit more. So this would be, this should be 2/2. Sorry about that. That should be 2/2. Okay, so this should be 3 plus 9, which is 12. And then 12 plus 1/2. Okay, so that'd be 25/2. Because 12 is 24/2. Okay, all right. That's the question. That's the answer to part A, 25/2. F of -5 is 25/2, or 12.5. Okay, you could write 12.5 too. So for part B, we want to evaluate the integral from 1 to 6 of g of x dx. And what we're going to have to do is we're going to have to break this up. We're going to have to break this up from from 1 to 3, because that's one function, and then from 3 to 6. So we're going to have to break this one up, okay? So we'll go to our paper and we'll do that. All right, so to find the integral from 1 to 6 of g of x dx, what we're going to need to do is we're going to break it up from 1 to 3 and then 3 to 6 because they're different functions, okay? So this is equivalent to the integral from 1 to 3 of g of x dx, and then plus the integral from 3 to 6 of g of x dx. Now from 1 to 3, that's just a square right here, right? So that's just 2 by 2. So we can get the area, the integral here by just finding the area of the square, which is 2 times 2, or if you wrote 4 there, that'd be fine, okay? And then plus, and then we want to do the integral from 3 to 6, right? So the integral from 3 to 6 is this function 2 times x minus 4 squared dx, okay? So a couple things, I'm going to pull my 2 out. I'm going to let u equal x minus 4, and then du would be, because I have a inside function inside this squaring function, okay? So you want to use integration by substitution. So du would equal dx, okay? And so this would be 4, and then plus, and then I'm going to bring the 2 out, and this is going to be u squared, and the dx just becomes your du, so it's u squared du. Okay, and we want to evaluate this from 3 to 6 for x's, but we just changed it to u's, so we need to switch these to u's. So if x is 3, then u would have to be -1, and when x is 6, u would have to be 2. Okay, so this is equal to 4 plus 2 u cubed over 3 evaluated from -1 to 2, right? And it's only this piece that we're evaluating, okay? Because that's where the integrals, actually I should do this to make it clear. Okay, so this is 4 plus, and this would be 2 times 2 cubed over 3 minus 2 times -1 cubed over 3, close my bracket, okay? All right, so then this becomes 4 plus, and this would be 8 times 2, which is 16, so 16 thirds, and then minus, I really don't need the brackets now, okay? Minus, right, this is going to be -1 times 2, right? So -2, but I'm subtracting, so it's actually, this is going to now become plus 2 thirds. 16 and 16 thirds plus 2 thirds is 18 thirds, which is 6. So this is 4 plus 6, which is 10. So my integral here is 10. Okay, and that's part B. So let's go on and let's do part C. So they're asking you on the open interval -5 to 6, on what open intervals is the graph of f both increasing and concave up, and then we need to give a reason for this, okay? So f is so let's figure out the increasing first. So f is increasing where f prime is positive. Well, we're given the graph of g, which is f prime. So f prime would be positive wherever this graph is above the x-axis. So wherever this graph is above the x-axis, for those x values, okay, f would have to be increasing, okay? Now, how about the concavity of it, okay? So concave up, that means the second derivative would have to be positive, okay? What on this graph is showing me f double prime is positive, okay? Well, we're given the graph of f prime, so one derivative away from that, right? That would determine where this is increasing, would determine where f double prime, the next derivative of this, would be positive, okay? So if this function's increasing, that means the next derivative of this would have to be positive, which this next derivative of this would be f double prime, okay? So wherever this is increasing, which is right here, okay, it's increasing, which means the derivative of this, which is really the second derivative, would have to be positive, which would mean f is concave up on this interval. Now there's another place right here, and it's right here, okay, because there it's also increasing. So we're looking for where where f prime is above the x-axis and also where f prime is increasing. If it has those two things, where f prime is above the x-axis and f prime is increasing, these two things hold, okay? All right, so let's go to our paper and answer this. So we would say f is increasing and concave up on the open interval 0 to 1 and 4 to 6. Because f prime of x, which is equal to g of x, is greater than 0 and f prime of x is increasing on the intervals 0 to 1 and 4 to 6. So basically by saying greater than 0, f prime is greater than 0, okay, that's saying above the x-axis. And f prime is increasing, okay, so this is f prime is increasing means f double prime is positive, okay? So here f prime is positive and f double prime is positive because f prime is increasing, okay, on these two intervals. And that's why we can say f is increasing and concave up on those two intervals, okay? And that's all you have to say for part C, okay? Let's go on to part D. So for part D, it says find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. Okay, so points of inflection are going to happen where f double prime changes signs. Well, we're given the graph of f prime, so we can tell the signs of f double prime by looking at f prime and see where it's changing from increasing to decreasing or decreasing to increasing, okay? And wherever that happens, that means f double prime would be changing signs, which would mean you have a point of inflection, okay? All right, so if you look, okay, where does this happen? Okay, so f prime is not increasing here, right? Or decreasing. Okay, now it's increasing, but then after that, it's not increasing or decreasing. Okay, after that, it's increasing, but after that, it's not increasing or decreasing, right? And then here, from 3 to 4, f prime is decreasing, and then from 4 on, f prime is increasing. So this is telling me the second derivative is negative, and right here, my second derivative is positive. So the second derivative changed from negative to positive. That's a point of inflection at x equals 4. And that's what we need to say, just what I just said out loud, okay? So we'll write it on our piece of paper. So we would just say f has a point of inflection at x equals 4 because f prime changed from decreasing to increasing at x equals 4. And that's enough justification, okay? That's the reason why, okay? All right, that's it for this 2018 question number 3. This was an interpreting graphs problem, okay? So the next problem we're gonna do, we'll do the next one, okay? All right, so that's it for number 3. So free response question 4 from the 2018 exam, they're giving you a table of values and they're giving you the height of the tree and it's a twice differentiable function. And then they ask you questions regarding this. Okay, so this is a table question. Okay, so I want to go over that again today. All right. Okay, so let's go ahead and let's look at part A. It says use the data in the table to estimate h prime of 6. Using correct units, interpret the meaning of h prime of 6 in the context of this problem. Okay. So to find h prime of 6, okay, so we're not given the actual function, so we can't take the derivative. So we have to use an average rate of change to estimate this, okay? So we'll do that in part A. So we'll go to our paper and do that. So h prime of 6 is approximately, okay, since we want to do it at 6, then what we want to do is pick 6, and it's between 5 and 7, right? So we want to use these two values, okay? So we want to do h of 7 minus h of 5. So h of 7 minus h of 5 over 7 minus 5. That's just slope, right? Okay, and then h of 7 is 11. So 11 minus 6 over 7 minus 5. 11 minus 6 is 5. 7 minus 5 is 2, right? So this gives you 2.5, okay? All right, now for the interpretation part, okay? So what does this mean, okay? What are the units on this, okay? So what are the H units? It's meters. So this is meters per, and the 7 and the 5 are years. So this is 2.5 meters per year, okay? So the correct interpretation of this would be at t equals 6 years, okay? The height of the tree, because that's what h describes, right? And this is telling you the rate at which it's changing, okay? So the height of the tree is increasing (2.5 meters per year. And you included the unit that we're finding, right, at 6, okay? And we're describing what this is. And that's all you need to do on this, okay? All right, let's go to part B. Okay, so explain why there must be at least one time t for 2 less than, or 2 less than t less than 10, such that h prime of t is equal to 2, okay? So this is they're testing you on the mean value theorem here, okay? And you need to show that in this interval, for some time interval, okay, that this is gonna happen, okay? Now, normally we would check the 10 and the 2, right? So if you look, the difference in the years from 2 to 10 is 8 years, okay? And then the difference in the height of the tree would be 15 minus 1.5, right? So 15 minus 1.5 would give you 13.5. And if you divide that by 8, it won't give you this 2, right? Okay, so what you have to do is look at this and go, is there some interval within 2 to 10 that it would give you this, okay? And if you look right here between 3 and 5 years, right? This height, the height changed by, increased by 4 meters, right? In 2 years, okay? So 4 meters in 2 years, that'd be 2 meters per year. That would give you a derivative of 2. So we have to use this part right here, okay? Within the 2 to 10, we have to use 3 to 5. That's what makes this one, part B here, a little bit more difficult because you had to find it. It's usually, a lot of times on these mean value theorems, it's these two, and show that this is true, okay? Like kind of like this one, okay? But you don't usually have to find the two values within this interval, okay? All right, so we'll do this right now, and we'll do the correct write-up here on part So the very first thing you need to do on part B is we need to establish that h of 5 minus h of 3, that's going to give you the 2 that we're looking for, okay? So this is 5 minus 3 is equal to, okay, so h of 5 was 6, and h of 3 was 2, and then 5 minus 3, and that would be 4 over 2, which is 2, okay? So what we have to show, okay, they tell you that h is a twice differentiable function, right? So you have to say, okay, h is differentiable on, and really technically it only has to be the open interval, but we're going to do the closed interval, okay? From 3 to 5. And therefore, because if it's differentiable, it has to be continuous, and therefore continuous on this closed interval 3 to 5. Now, really, it has to be continuous on the closed interval and just differentiable on the open. But if it's differentiable on the closed, which it is, it has to be differentiable on the open also, okay? We just need the closed to establish that it's continuous on the closed, okay? All right? Okay. Then by the mean value theorem, there must be a C. And then where is that C? Well, it's in between 3 and 5 with 3 less than C less than 5 such that H prime of, you know what, let me change, H prime of T is equal to 2, because they told you H prime of T, right? Let me change this. Instead of saying C, calling this C, let's call it T. Okay, there must be a T with 3 less than T less than 5 such that H prime of T is equal to 2. Okay, and that's what the mean value theorem says, because if you can establish that it's differentiable on the open, continuous on the closed, okay, and you have a average rate of change that's equal to this, therefore there must be a derivative in between these two values of T, okay? All right, so that's part B. In all honesty, probably part B and part D in this problem are the hardest, okay? So you just have to know what the meaning of, therefore, there's E after that, okay? You have to know the mean value theorem, right, to do this problem, okay? Now it is on your sheets, right? Those cardstock sheets that I printed up for you, okay? So let's go to part C and let's do that one. So for part C, it says use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree over the time interval 2 less than or equal to t less than or equal to 10. Okay, so we want the average height, right? Now, what if we just do the trapezoidal sum? Then what you would get is you're going to be multiplying heights times years. So you'd be getting meter years. That would be your units, right? So we need to divide by the time unit also to get back to meters, because we're asking you for the average height. Well, the average height, the units would have to be meters, okay? So this is the average value of a function, okay? And we're going to do that next, okay? So they want to find the average height over the time interval 2 to 10. So that would be 1 over 10 minus 2, and then the integral from 2 to 10 of h of t dt. And this is what I meant earlier by, if we didn't do this part, right? If we just did this, this is meters and this is years. So when we integrate this, we get meter years, which is not a unit that we're accustomed to, right? But these units down here are years, right? This is going to be 1 over 8 years, okay? So if we are multiplying by years, but we're also dividing by years, they're going to cancel out, and we're going to be left with just meters, okay? So this is equal to 1/8 times the integral from 2 to 10 of h of t dt. And now we're going to use a trapezoidal sum to do this one, okay? To do that integral. So this is 1/8 and then bracket, okay? And then the trapezoidal sum, okay? Remember, it's the height, right? 1/2 the height times the sum of the two parallel bases. These are my two parallel bases. My height is my delta x. So this would be 1/2 times 1 times 1.5 plus 2. Okay, that's my first subinterval, and they said to make 4, right? So then plus the next trapezoid would be 1/2, and the height would be between 3 and 5, which is 2. So 1/2 times 2 times 2 plus 6, because those are my two parallel bases, right? 2 and 6. And then plus 1/2. Okay, and the next one's between 5 and 7, so that'd be 2. And then the heights would be 6 and 11. So 6 plus 11. And then plus 1/2. And then we can go from 7 to 10. So that height is 3 times 11 plus 15. Okay, so this is equal to 1/8 times 1/2 times, and this would be 3.5 plus, and this would just be 2 plus 6 plus, and then 6 plus 11 is 17. Well, here my half times 2 cancels out again, right? And so this would just be 17. You could also write this as just, this one's just 8. Okay, and then plus, and then this would be 11 plus the 15, right? Which is 26, and half of 26 is 13. So this would be 3 times 13. So this would be 1/8 times. And you know what, guys? Really, what I would do is change this to fractions, okay? 3.5 is 3 1/2, right? So that'd be 7 halves. So 1/2 times 7 halves would be 7 fourths, okay? Because this is 7 halves times 1/2, that'd be 7 fourths, plus 8 plus 17 plus 39. So this would be 1/8 and then 7 fourths plus, okay. So this would be 56. 56 and 8 would be 64. I'm just checking my math in my head. Yeah. And then this would be 7 32nds plus 64 eighths. Okay. And so I'm going to want to multiply by 4 over 4, right? And get a common denominator. So this is 7 over 3. You wouldn't have to do this, okay? If you stopped right here, actually right here, if you had stopped right here, you'd get the right answer, okay? Because it's a numeric answer. Okay, so this would be 240 and 16, 256. So plus 256 over 32. And so that would give you a final answer of 263 over 32. And that would be your answer for part C. That's the average height, okay? Because, okay, so all of this in here gives you meter years, and this is years. So this is just going to be meters right here. Okay, so that's the average height of the tree between years 2 and 10. Okay, all right, let's go on to part D. Okay, so for question 4, what they're asking you for is the rate at which the height of the tree is increasing when the height is 50 meters. Now, this is G and G of X are the same thing. So the height is determined by the diameter from this formula, okay? The diameter of the base of the tree. And then they're telling you that this base, the diameter, is increasing 0.03 meters per year. So if X is the diameter of the base, then this would be dx over dt, because they're telling you how this is changing, right? And it's increasing 0.03 meters per year. Okay, so let's go to our paper and let's go ahead and try to answer part D. Okay, so for part D, they're giving us the function g is equal to 100x over 1 plus x, okay? And they want to find the derivative with respect to time. So we're going to take d dt of both sides and d dt of 100x over 1 plus x. Okay, so d dt of g would equal dg over dt is equal to, and then the derivative of this, well, we're going to have to use the quotient rule, right? So the derivative of 100x would be 100 times dx over dt times the denominator, which is 1 plus x, minus the numerator, which is 100x, times the derivative of the bottom with respect to time, right? So that'd be dx over dt over 1 plus x. Okay, so the dx dt's become 0.03s, right? Because in the problem, they told you when g is equal to 50, the diameter is increasing at a rate of 0.03 meters per year, right? Okay, so we also need to know to use this, right? Because they want to know this when g is 50, right? But to know this, it's not dependent upon g, it's dependent upon the x value, because we need the x, right? Because the x is in the formula, and dx dt. We have the dx dt, what we don't have is x. So what is x when g is 50? Well, we can use our original function to do that, right? Because g is 50, right? 50 is equal to 100x over 1 plus x. We could multiply both sides of this equation by 1 plus x, and we get 50 plus 50x is equal to 100x. And then subtract 50x, and you get 50 is equal to 50x. So that means x would have to equal 1, okay? So when g is equal to 50, we also know that x is equal to 1. The diameter of that's the diameter of the tree. The diameter of the tree is 1 meter, and the diameter is increasing 0.03 meters per year, okay? So what does that mean? We got to find, they're asking you to find dg dt at g is equal to 50, but that's the same as saying x is equal to 1, okay? So that would equal 100 times, and then dx dt we know is 0.03 times 1 plus 1, because x is 1, minus 100 times 1 times 0.03 all over, you know what? I forgot to write 1 plus x squared. Okay, so that's 1 plus x squared. Okay, that's the quotient rule, right? It doesn't stay just 1 plus x squared. And then this is 1 plus 1 squared. Okay, so then this is equal to 0.03 times 100 is just 3. So this is 3 times 2 minus, and then this would be 3 times 1, which would just be 3, over 1 plus 1, which is 2, squared is 4. And then this would be 6 minus 3. So this is 3/4. Now, what does that mean? What are the units on this? Okay, so the units for G is meters, and the units for time is years. Okay, so let's write a statement, okay? What this means is when the height of the tree is 50 meters, the height is increasing 3/4 meters per year. Okay, and that's the complete write-up on this. Okay, so this is a related rates problem. I don't know if you realize that, but that's what this is. It's just a simple, well, no, I shouldn't say simple. It's not simple, but it's a related rates problem. Okay, all right, that's dealing with because they're asking us the rate at which the tree was growing, but they gave us the rate at which the diameter was increasing, right? Okay, and so we had to use all that to figure it out. All right. Okay, so that's part D, guys, and that's it for today. All right, you guys take care. Bye.